And hello guys, welcome back again to another part in my DIY analog synthesizer videos. And today we're going to be looking at the RH1 board again, synthesizer board, which is a single oscillator, single voice, monophonic synthesizer DIY project you can put together yourself. And as I showed you last time, this is the board from RH Electronics. Don't forget to go over to rh.electronics.co.uk and you can find out more information on this synthesizer and order yourself one. Also, you go over to his YouTube channel and he either does these boards unpopulated or populated for a fee. Okay, so what I have here, I've managed to download and print, is pretty much kind of the manual and lots of various information on how all these synthesizer works. I'm not going to go through the whole thing as this is not quite the purpose of the video, but from what I did, the information I did get, we managed to find the bill of materials. So on, doesn't exactly say which page here, it just gives you basically a list of the various components you need. As you can see, we've got all, it's not too critical as to the tolerance of the resistors, but I try and use 1% if I can, or 0.1% metal film resistors. As we can see here, we've got a couple of transistors which are quite sort of 10 to a penny, a couple of signal diodes here, the 1N4148, and this is a special diode here which is the 5V1 Zener diode. When you get the board, this 78M05 is a 5-volt regulator. This already comes pre-soldered to the surface mount, soldered to the board. As you can see here, we've got things like a crystal oscillator. This is for the, I think this is for the timing of the pick, and it's very important you keep it at 4 megahertz, otherwise it can throw the pitch out, because basically the way the pick works, it generates a square wave, which is your rising edge of your oscillator frequency, or your because we generate a sawtooth. We derive a sawtooth and we derive a square stroke pulse wave from that pick, which actually runs into more circuitry. We basically have a DCO, which is kind of loosely based on the Juno 106 style. Yeah, we can see here we've got, it gives you a rundown of all the Molex header connections that you need, which are, sorry about that camera glare, which are here, all here at the bottom. And as we can see, we have the MCP 4922, which is I think this is a dual channel 12-bit DAC, also known as a digital to analog converter. We have our 4N25 opto isolator, which picks where you use MIDI into, and this sends your MIDI data out to the DAC, when DAC converts that to an analog voltage. We've got a couple of op amps here for various duties, including buffering, etc. And we have the sort of second generation of, or should I say, second generation. These are kind of copies of the Curtis chips. You've got the 3360, the 3372. I think one of these is an envelope, could be this 3310, which is the envelope. We've got an analog switch, the 4066, which is quite easily obtainable parts. It's just that you have to be quite specific about making sure you have that Zener diode, which is the 5V1, which he was kind enough to send to me. It looks like a signal diode, but please don't get these mixed up. So what I'm going to do now is actually place this diode into the board. Let's try and find that. There it is. Make sure we've got the orientation the right way around. If you look at the circuit board, we've got all the values printed on there, and we just need to keep an eye on what material capacitors we're popping in, because some of these capacitors will be for decoupling. Normally, if you see a 0.1 UF or 100 nanofarads, it's calling for ceramic capacitor to decouple and keep your IC stable. normally between your live voltage rails and the ground, or your 0 volts. And we've got our power supply in. We can also put a header for Eurovac here. I think what I'm going to do is probably use my last spare power supply I have, which was from Frequency Central, and just change the regulators over to a plus 12 and a minus 12 regulator. Yeah, not too a hell of a lot to say about this at the moment. And I'm basically going to start by populating this board with the lowest sort of profile components, which is normally the diodes. Then I will go over to the resistors, and then most probably the IC holders, because I'm going to put everything on IC holders, just so that if we do get any problems, you can easily pop the integrated chip out and replace it with another one should you get it wrong and burn one out by accident, or it's faulty, etc. And then go for the Molex headers, and then for the taller, the polystyrene, or should I say the I can't even pronounce the word, poly something capacitors, you know, the sort of box style ones, the small box style capacitors, and then put in these sort of electrolytic capacitors, and then we should be pretty much home and dry. And it does go through here on what you need to do upon hooking up of the power supply. It gives you some tips on not actually popping in the ICs first and actually hooking it up to power and testing your power points and making sure you're all good before starting to put in the chips. So yeah, so like I said before, I'm not going to go through soldering this sort of live. I'll sort of give you sort of small updates as you can see how this will turn out. Hopefully I can get all the components together quick enough and we will be at a stage to get up and running. Right, anyway, if there are any further questions, please leave them in the comments, or as I said, go over to rh.electronics.co.uk. I will leave a link in the description, and don't forget to like and subscribe, people. Thank you for watching, thanks for your time, and I'll catch you all very soon.